Hello friends, welcome back. In this video lecture, we are going to solve an example on the Gauss-Seidel method for a given power system, and here we are going to use the acceleration factor. Okay, so now let me just write the statement of the problem and let me draw the diagram of the given power system. So here, 3-bus power system is a 3-bus power system is shown in figure below. Okay, and the relevant per unit line admittances, the relevant per unit line admittances on line admittances on 100 MVA base are indicated on the diagram on the diagram and bus data are given in and bus data are given in table. Okay, from Y bus and from Y bus, not from Y bus, and determine the voltages at bus 2 and 3. The voltages at bus 2 and 3 after the second iteration. After the second iteration using Gauss-Seidel method. Using Gauss-Seidel method. Take the acceleration factor. Take the acceleration factor alpha equal to 1.6. Okay, so here is the given diagram. 3-bus system. Okay, so to this bus number 1 generator is connected. So this is bus 1, and to bus 2 one generator is connected, and also there is one load. Okay, and to the bus 3 there is a load. Okay, and the line admittances are given here. So already they have mentioned that these values are calculated as per unit value on the base of 100 MVA. So these are all per unit minus J5. Okay, so these are the per unit admittances given for the transmission lines connecting the two buses. Okay, or between the two buses. Now they have given another table for giving the other information. So here in the table they have given. Okay, so I'll just write this table now. Bus number. Okay, then what type of bus it is, then generation information they have given. Okay, so in generation, two types of generation, active power and reactive power. both in megawatt. Then load, so load is also in megawatt, active megawatt and reactive megawatt, reactive MVAR, sorry, MVAR, MVAR, and then finally bus voltage. Okay, so here V per unit and delta in degrees. Okay, so now what they have given here is for bus 1. Okay, which type of bus is slack bus, and for slack bus we know that P and Q are unknown. Okay, as well as no load is connected, so 0 0, and they have given the voltage value as 1.02 per unit, and degrees phase angle is 0 degrees. And the second bus here is PQ bus, that means P and Q value are known. Okay, so P and Q value are known, and also it is having load of 50 megawatt and 25 MVAR. So here voltage and phase angle are unknown. So third bus is also PQ bus. So for PQ third bus there is no generator, so 0 0, but there is a load. So active load is 60 megawatt and reactive load is 30 MVAR, and here P and Q should be unknown. Okay, so this is what the given information is. Now based on the information given here, so we need to determine the parameters of bus 2 and 3. So here bus 2 and 3 are PQ bus, therefore the unknown parameters to be obtained are voltage and phase angle at bus 2 as well as at bus 3, and this should be obtained for second iteration. Okay, so before obtaining that we need to first of all determine the uh, that Y bus. Okay, so therefore here we need to first calculate the elements of the Y bus. So directly they have given the admittances for each of the bus. So the admittances of the diagonal elements of the Y bus will be Y11, Y22, Y Y22, Y33. Okay, so now these are nothing but the admittances connected to each of the bus. So for bus 1 the two admittances are minus J3 and minus J4, so we need to just add those three. So minus J3 minus J4 equal to minus J7, it is per unit value. Same way for the bus 2, so minus J3 and minus J5, so this will be equals to minus J8 per unit. Similarly for third bus, it is minus J4 minus J5. Okay, minus J4 and minus J5, so minus J9 per unit. Similarly we need to determine the other elements, so like Y12 which is equal to Y21, which will be equal to minus Y12, what is connected between 1 and 2. So here minus of minus J 1 and 2 is 3, so 3, so it will be plus J3, which is also per unit value. Similarly Y13, which is nothing but Y31, which will be equals to minus Y13, what is connected between 1 and 3, minus J4, so minus of minus J4 is plus J4 per unit. Similarly Y23, so it will be also Y32, which is minus Y23. So what is connected between 2 and 3, it is between 2 and 3, it is here, this is second bus and this is third bus, minus J5, minus of minus J5, that is going to be plus J5 per unit. Okay, so these are the admittances that are available on the various admittances of the elements of the Y bus. So therefore the Y bus is equal to, for 3 bus system, so Y bus is given by Y11, Y12, Y13, Y21, Y22, Y23, y31, y32, y33. Okay, so now substituting these values here, so y11 minus j7 plus j3 plus j4 plus j3 minus j8 j5, then j4 j5 minus j9. Okay, so these are the y bus. Okay, so first part is clear. Okay, so now we shall calculate the bus powers. So here the bus powers are not given directly, but they have been given in terms of the megawatt and uh, MVR rating, but we need to obtain for the base value. And for a particular base, if there is a generator as well as there is a load, okay, so there is a generator as well as a load, so this load will be taken as negative value and this will be taken as positive, which is a generator. Okay, so therefore here we have to actually find out the total power on that particular bus, then we have to obtain the base value of that. So therefore here, so now we shall calculate bus powers. Okay, the powers of generator are taken positive and the powers of load are taken negative. Okay, so therefore at bus 2, okay, so at bus 2 the power will be indicated as P2, and here there is a generator as well as there is a load, so I will write it as Pg minus PL. And what is the base? So here base MVA we have to write, they have given base MVA as 100. Okay, so that we need to substitute here. So now here if you observe the given diagram, okay, so this diagram here, so there is a generator and there is a load. So now on the bus 2, okay, so what is the generator value, active generator value here 25, and what is the load value 50. So we have to take plus 25 and minus 50 and divided by 100, so we'll get the PU. So it is minus 0.25 per unit. Okay, so same way for we can obtain uh, reactive power. Okay, so which can be written as Qg minus QL. It is also in the same way. Okay, so here we have to take base MVA. So now Qg and QL. So what is Qg for the bus 2? So Qg is 15 and QL is Qg is 15 and QL is 25. So 15 minus 25 divided by 100. So we're gonna get minus minus 0.1. Okay, so minus 0.1 per unit. Okay, so similarly we can calculate at bus 3. So at bus 3 P3. So now at bus 3 P3 again we can write Pg minus PL divided by base MVA. So now what is Pg here at bus 3? At bus 3 Pg is 0 and PL is 60. So Pg is 0 minus 60 divided by 100. So it is going to be minus 0.6. Okay, 60 you can write Q. Similarly Q3 will be equal to Qg minus QL at bus 3. So base MVA. So again if you observe here for the bus 3 they have given Qg also 0 and QL is 30. So 0 minus 30, okay, divided by 100, which will become minus 0.30 per unit. Okay, so these are the base values of powers on the buses. bus number 2 and bus number 3. Okay, so now what is required here? Here voltages are required on the bus number 2 and bus number 3. Okay, so therefore we need to first of all assume some values here so that we can use it while obtaining the uh, iterated values. Okay. Okay, so I will first write it here. First iteration. Okay, so for first iteration, so already we have to write what is the given information. So given is, so v1 is given, which is 1.02 at an angle of 0 degrees, and we need to assume vk of 0, or say v2 equal to v2 of 0, we can say it will be 1 or 1.0 per unit. v3 of 0 is also 1.0 per unit. Del 2 of 0 is going to be 0 degrees, and del 3 of 0 is going to be 0 degrees. Okay, so that is the initial values that we need to assume. Okay, now the voltage bus 2 is given by v2 of 1. First iteration is indicated as 1, so v2 of 1 equals to 1 divided by yii, which is 1 upon y22. So p2 minus jq2 v2 rth iteration. Okay, so here rth iteration is nothing but the 0th iteration, so I'll directly write it as v2 of 0. Okay, minus, so here 2 is taken out, so k equal to 1 to 3 we have to take, so remaining k values are k equal to 1 and k equal to 3. So y2i is same 2, y21, so here it is v1 minus y23, k equal to 3, because k equal to 2 term with I equal to 2 is already taken outside, so here it is not considered. So v3 and v3 of 0. So v1 is already specified, so no need to mention the here whatever iteration we are using, because it will be remaining same all the time. It is specified quantity. Okay, so now substituting the values of this all parameters here. So y22 already we have obtained as minus j8. Okay, so you can check in the that matrix, y bus matrix. Okay, therefore p2 we have calculated, which is minus 0.25. Okay, plus j.1. Okay, minus of minuses plus denominator is 1 at an angle 0, minus y21 is j3, and it is v1 is 1.02 at an angle 0, minus y23 is j2, sorry, j5, and v30 we have assumed 1 at an angle 0, or 1 plus j0. Yes, so whatever you can write. Okay, so now simplifying this, so we're gonna get, so you can do the simplification yourself, so I'll just write the final part here. Okay, so which is 1 divided by minus j8, in the bracket you will get minus 0.25 minus j.96. okay, so which you can simplify, and finally you will get this value as, okay, in terms of rectangular form, 0.995 minus j.0312, which can be written in the polar form as 0.9955 at an angle of minus 1.799 degrees. Okay, so this is the first iterated values that we have obtained. Okay, so now here after first iteration we have to use the acceleration factor and try to determine the accelerated value. So therefore for that we need this del of v21, which is nothing but v21 minus v2 of 0. Okay, so here 0.995 minus j 0.0312 minus 1.j0, which is going to be minus 0.005 minus j 0.0312. Okay, so this is the that del value difference between the two values. Okay, now the accelerated value of v21. So v21 accelerated will be equal to v2 of 0 plus alpha del of v21. Okay, so v2 of 0 is 1 plus j0 or 1 at an angle j0 plus acceleration factor is assumed to be 1.6, and the new value that we have, or the difference value that we have written, is minus 0.005 minus j 0.0312. Okay, so simplifying this, we're gonna get this accelerated value is 0.992 minus j 0.0499. Okay, so here this is more nearer to the desired value. Okay, so that you can compare here whatever we have obtained, it is 0.9955, and here angle this j term is 0.0312. Now because of the acceleration factor, so this 0.99 has been improved by, say here it was 55, now it is 2, and here imaginary term is also improved. Okay, so because of which the required result will be reached sooner. Okay, so in less number of iterations. Okay, so now we will see the remaining part of this solution in the next video lecture. Till then, just go through the steps once again and come up to this particular point, and next you can continue in the second part of this video lecture. Okay, till then, happy learning and thank you.